Okay, let's continue with our review for similar figures. We're on slide 5. And this one says to find the value of x, and x is this segment of the smaller rectangle here. So the best thing to do is just redraw your rectangles. So first here's my small one, and there's my x, and this segment is 2.5 meters. Let's draw our bigger rectangle, so separate them and draw them separately, and that makes things a lot easier. And the measurement here is 7, and this is 24.5. And we'll go ahead and designate x as side 1, so 24.5 would be side 1, and 2.5 would be 2, and so that would be along lines with the 7. Rectangle A, rectangle B. So let's go ahead, and if we do side 1 over side 2, and label our A and B, so this would be x is to 2.5 as 24.5 is to 7. So our cross product 7x equals 24.5 times 2.5. So 7x equals 61.25. Divide both sides by 7, and x comes out to 8.75. All right. In our beach picture, it says how deep is the water. So the best thing here again is to take these two triangles and redraw them separately. So we have this little triangle here. So let's go ahead and draw that one. And the measurements there would be 8 and a 1. And our large triangle, so here's our H, which is what we're looking for, how deep the water is going down here. And this would be a 50 to H. So let's designate H as side 1, and then our longer sides is side 2. We'll call our little one A, our big one B. So side 1 to side 2, A and B. So our little triangle, side 1 is 1, side 2 is 8. And B, side 1 is our H, our missing number, and 50 is side 2. So using our cross products, 8H, and 50 times 1 is just 50. So we divide both sides by 8. H is going to be equal to 6.25 feet. Okay. And slide 6. There is an amusement park question here. It says the triangles in the figures are similar. How far is the water ride from the roller coaster? So here's our water ride and here's our roller coaster. So we are talking about D here, okay? And so this is D meters. So let's go ahead and if we designate our sides, the two lines here indicate those angles are congruent. And in our triangle here, the smaller one, those are the two angles. So this side has to correspond to that side. So we'll name those side 2. The fact that these two angles are congruent mean that these opposite sides are also congruent. So this would be 45 and this would be 21. Now, let's go ahead and name our big triangle A, our little triangle B. And we'll do our side 1 over side 2. Our A and B, and let's go ahead and set up our proportions. So in triangle A, this is our unknown D, and side 2 is 45. Triangle B, side 1 is 10, and side 2 is 21. So doing our cross products, 21D, 45 times 10, we know it's already just 450. And when we divide both sides by 21, all right, D is going to be equal to 21.42 meters, and it wants us to round to the nearest tenth, so the 2 does not do anything to the 4, so it would be 21.4 meters would be your answer. All right. Next question, a flagpole question. All right, it says Lena is 5.5 feet tall and casts an 8-foot shadow. At the same time, a flagpole casts a 48-foot shadow. How tall is the flagpole? So let's go ahead and first change that to 5.5. A little easier to use decimals versus fractions in our proportions. So let's go ahead. The two things we're talking about is the shadow versus the real object. And the two objects we're talking about are Lena and our flagpole. So we've kind of got our rows and our columns set up. It's really just a matrix here. And we go ahead and put our numbers in. So it says Lena is 5.5 feet tall. So Lena, her real height would go in the denominator, 5.5. Her shadow is 8 feet, so that would go in the numerator. At the same time, a flagpole casts a 48-foot shadow, so flagpole and shadow, 48. So our missing value, n. So 8n equals 48 times 5.5, and that comes out to 264. 264, sorry about that. And when we divide both sides by 8, n comes out to 33 feet tall for the flagpole. All right. And our model car question here. It says, for exercise, use the following information. A scale model racing car is 11 inches long, 3 inches wide, and 2 inches tall. So let's go ahead and write that down. So on the model, all right, it is 11 inches long, 3 inches wide, and 2 inches tall on the model. Now this is telling us that the real car is 22 feet long. So we'll use our model numbers and the real numbers here to solve these problems. So it wants to know how wide is the actual racing car. So what we can do is go ahead and set this up as model over real. And since we are given the real length, we can use the length, the model length, and the real length of the car to set up our first ratio. So we know that on the model, the real length of the car is 22 feet, and the model is 11 inches. So now we can set up our next proportion to figure out the width. So the width on the model is 3 inches, all right? And so now we have n down here. So we set up our 11n equals 3 times 22. 11n equals 66. We divide both sides by 11, and n is going to be equal to 6 feet wide. The next question wants to know how tall the real car is. And so again, let's go ahead and set this up as model over real. And we'll use that first ratio. 11 inches is 22 feet because that's the information that is given, so we can use that. And we want to know how tall the actual car is. So over here in our, we know that the model is 2 inches tall. So I can use 2 up here, and then my missing value will be the real height of the car. So 11n equals 22 times 2. 11n equals 44. And when we divide both sides by 11, n is going to equal 4 feet tall. All right, good job, and good luck with your test tomorrow. Thanks for checking in. It is much appreciated.